Hi everyone, welcome to today's session wherein we'll discuss why it is so important to learn data structures and algorithm. Uh, because if you will just think about learning a programming language, it's all about, hey, what's the history of the programming language, how to compile the program, what are the different data types, what are the different looping construct, what are the different relational comparison construct, how can you do file handling. So in this whole narrative of learning a programming language, the essence that how to write an optimized program, because end of the day, your program will be taken up in RAM, CPU will be given to it, it being converted to a process. So what's end of the day happening is your program or the process is consuming CPU cycles and the storage on RAM. So somehow the intent is to optimize both. Because if my memory footprint on RAM is less, I'll be able to get the same amount of work done in less amount of RAM usage. And same goes for my CPU cycles. If I somehow try to reduce my CPU cycles and still get the same result, I am doing, or rather, I am optimizing the usage of my resource. And as a result, less time will be required to get the work done. And at the same time, less money will be spent on getting the work done. My name is Kunal Gautam. I work as a principal architect for one of the bank companies in the industry for 16 plus years, had my own startup and have given multiple big data and AI/ML key as a keynote speaker at Budapest, Korea, India, US, and Southeast Asia. So again, just a quick review that your computer is mainly comprising of four components: CPU, RAM, disk, and network card. CPU has CPU cycles and it's measured in gigahertz per second, how many instructions per second it can execute. RAM has storage and also the IO. Disk has storage and also the IO. Network card only has the IO. It doesn't has any storage capacity. So if you have a Python program or a Java program, it's pulled from the disk onto the RAM. CPU cycles are given to it, and that's how the execution start. So in very simple terms, when you're writing the program, there are two intent with which you should write the program. First of all, how can you optimize the allocation on your RAM? And secondly, how can you optimize the CPU cycle? How can you minimize the usage of CPU cycle? So just a quick review once again that if you have a Python program, you go ahead, you compile that, you run Python, and then the name of the file. What Python internally does is it interprets slash compiles, generates a bytecode that's consumed by your virtual machine, and the virtual machine, which is the Python virtual machine. And the Python virtual machine is a program, or rather a process, which interacts with your OS to keep allocating memory in your RAM and also getting allocated CPU cycles. That's how your Python program gets to do the work that it is supposed to do, or the way the code has been written. So I just want to emphasize you are able to appreciate the fact that while writing the code, these two are implicit ideas that you should be looking at and on how to optimize the code. So overall, two outcomes are there. If I want to optimize the storage on the RAM and the CPU cycle. The first one is known as data structure, usage of right data structure for the right problem statement. And the second part is known as the algorithm, because if your algorithm is efficient, as in it requires less CPU, you will get to do the same work in lesser amount of CPU usage. Similarly, if you use the right data structure, then the memory footprint on the RAM will be minimized. So with this, we'll go on to a problem statement just to demo why you have to think differently, why you should be thinking out of the box, and why you should be focusing on learning data structures and algorithm, which forms the basis of computer science. So I have two arrays here, array 1 and array 2. And you can see the numbers, both of them are already sorted. All right. What I want to do is I want to create an array 3, which comprises of all the elements of array 1 and array 2, and it is also sorted in nature. Take a moment, think about it. Both the array 1 and array 2, which are input arrays, they are sorted in nature. I want a third array which comprises of all the elements of array 1 and array 2, but it should also be sorted. So first of all, let's look at the data structure. This is array 1 and it's defined like an array here, right? Just take a pause, think about it. Is this mapped to the RAM or the hard disk? So the answer is this is mapped to the RAM. So what it means is If my RAM is 2 GB and if I keep filling my elements here more than 2 GB, what will happen? My program will crash. The reason being, this array cannot be more than the size of your RAM. It's not possible because this data structure, or rather all the data structures that you will come across, linked list, trees, graph, they are all mapped to the RAM and not the hard disk. All the data structures which are mapped to RAM and hard disk, they come with a different flavor. All the data types across different programming language, be it Java, you use hash maps, you use list, you use set, uh, or be it your C++ code, wherein you used to again use the vectors and list and array and whatnot. They all were mapped only to RAM. They were not hard disk map data structures. So now what is a data structure? Data structure is a mechanism to efficiently store, retrieve, search my data on RAM. So let's look at one of the ways of sorting it to begin with. So what we are doing here is we are first of all creating a third array, the merged array. We are appending all the elements from array 1. I'm appending all the elements of array 2. So my third array comprises of all the elements of array 1 and array 2 now. And then we go ahead doing a bubble sort. What bubble sort means is you look at this thing, this loop here. It comprises of two for loops, and I'll explain you, or I will try to provide you a mental model through which you can understand what's happening. So bubble sort simply means that just look at the word bubble. The smallest element will somehow bubble at the end of the array. Able to visualize? So it's like there is a C. There is something the tiny whatever the lowest density element is at the bed of the C. It will automatically bubble up and come at the top. So if you have an array, what bubble sort says is take the smallest element from wherever and bubble it at the very end of my array. So let's look at the first loop. It starts with I range n. All right. The second one is starting at 0 and it is not at n minus 1. It is a element one more before. So you are not going, the second loop is not going to the end of the array. It's going till n minus 1 because the index of an array starts with 0. So anyhow, the last element will be indexed by n minus 1. You subtract minus I from there, this part from there. So now what is this? This is coming one more index before that. Now what we do is we start comparing. We take the first element and the second element because you are looping through j, 0 to what? So is j of 0 greater than 0 plus 1? If yes, then you swap it. So the first loop is there, which is the first loop. The second loop is iterating from 0 till n minus 1th element, n minus 1 minus ith element. And what it is doing? It is just comparing the adjacent numbers till it goes till the last. So what is happened is in the first pass, the lowest element has bubbled at the end of the array. Then I equals to 1 happens. It again does the same thingy, comparison, but n minus 1 minus I times, as in like it again goes ahead until the last second element, it does the swapping and figures out what is the second most smallest element in my array. And that's how it is bubbling up all the smallest numbers towards the end. When the loop ends, you will get a completely sorted array. A good catch here, I have also introduced a variable num comparison. Because anytime you are doing a comparison, that's where your CPU cycles are being leveraged. Even for the for card cannot, hard disk cannot. The logical part, or let's say the logical memory, or the logical capability of a computer is the CPU. So what we are doing is wherever we are doing a comparison, we are increasing this num comparison equal to 1. At a broad level, it simply wants to figure out how many times the comparison has happened or how many CPU cycles we have used. If one comparison is equal to one CPU cycle, this is the number of CPU cycles we have used. So this was one way of solving the problem. But this particular problem or solution works for any array. It can work for even an unsorted array. Think about it. Even if my array was unsorted, this solution will always work. So it means that I didn't leverage the fact that both my arrays were sorted. I didn't utilize that while developing my solution. It means that my algorithm was not optimized. There is a possibility that I can optimize my algorithm. So what we do is, this is the second solution. What we do here is, because my arrays, just create a mental model, you put the arrays this way, you have pointers pointing to the first element in each array. Both the arrays are sorted. So if both the arrays are sorted, all I have to do is I simply have to compare. Hey, which one of you is the smallest one? If you are the smallest one, let's say this one is the smallest one, I put that into my final array and I increment the index one level below. Now I do a comparison between this guy and this guy. Whosoever is the smallest, I put this one again in my final array and I move the pointer now. And this keeps on going on. Just keep in mind, both the arrays can be of the same length or might be of different length. So this has done the comparison. Rest of the element we go ahead and add in the array one, in my final array in this sequence. So now what happened is, instead of two for loops, I was able to achieve that in a single while loop. So two for loops means if first loop is going till n times, second loop is going till m times. So how many times the loop will execute if it's a two for loop? N into m. Because for every element in the first for loop, m times the second one will execute. For the second element in the first for loop, then again it will go m times. That's why n into m's. While if I do the same thing using the while loop, it is n plus m, because it's somehow a function of the length of array 1 and array 2. If both of them are equal, it will just stop here. If one of them is not equal, like one of them will be executed here, because one array has to be consumed. So either the array 1 will be consumed or array 2 will be consumed. All right. Again, I have put a num comparison here and I have added num comparison equal to 1 here, here, and here. If we run the code, you can see both of them, the bubble sorted array, which also works on a non-sorted array, did 45 comparison, as in 45 CPU cycles it required. While the second one was able to do the same thing in 9 cycles. It means that if I change my algorithm, less amount of CPU will be required to get the same output. It means this is a better algorithm as compared to the first one for the above problem statement. So what do we get from this session? The idea is, you should learn programming language, you should learn the internals of it, the memory management part of it, but just keep in mind your data structure, the choice of the data structure for the right problem, like why you should use dictionary instead of a list instead of an array. What is really happening? You should start appreciating that. So try to learn more and more data structures. So start with linked list, arrays, string, graph, sorting algorithms. So, graph is there. Then you can go with dynamic. So these are the these are the top data structure. Then in terms of algorithm, you have to start learning about sorting, searching, dynamic programming. So these are the algo that you should be focusing on. So if you have a good understanding of the programming language, along with the data structures and the algorithm, then you will be able to write the most optimized code, which will be leveraging, or let's say, which will be using CPU as well as RAM in the most optimized fashion, so that your algorithm will work in the least amount of time and will also have the minimum cost impact of the solution that you're building. So I really hope you appreciate it. What I'll be doing is I'll be providing the links of all the places from where you can learn algorithm and how much time roughly it should take. So this should be a good starting point. Just keep in mind, algorithms and data structure algorithm is pretty much like mathematics, because you can really see here you are doing comparisons. So you just need to practice it. you have to understand the data structure algorithm, and then you have to keep practicing it for a good 2 to 3 months to get a hang of it. Just keep in mind, if you don't practice, you'll forget data structure and algorithm. So that's one subject or topic that you need to practice on a daily basis. Allocate 20 to 30 minutes, do a couple of problems on a daily basis, but that's how you can become the master of data structure and algorithm. And once you have a very good, strong hold of data structure and algorithm, like writing an efficient code, yeah, especially in the days of Gen AI, is not a problem at all. The only thing is, hey, do I really understand my code? Do I have I written a really optimized code? That's what really matters. So thanks a lot, folks, and hope to see you in the next session.